Alrighty, so today we're going to have a quick investigation into expanding binomials and Pascal's triangle. So, in order to make this work, what we're going to do is we're going to look at a plus b to the power of 1, a plus b to the power of 2, a plus b to the power of 3, and a plus b to the power of 4. And we're going to investigate what each of these look like once we expand all the brackets out to see if there's a quicker way of doing this. Because later on, we're going to be coming up with things like, 3x minus 2 to the power of 8, and we've got to ask ourselves, is there a quick way of being able to evaluate that? And the answer is there absolutely is a quick way, but let's explore. So a plus b to the power of 1, well, it's just a plus b. Nothing too exciting there. Second one's a little bit more interesting. So this is a plus b, a plus b. We can expand out those brackets using the traditional method or FOIL, whatever your preference is. And we're going to get a squared plus ab plus ba plus b squared. Or after collecting like terms, because these are both ab, we get 2ab plus b squared. So that's those brackets fully expanded. For a plus b to the power of 3, well, that would just be the same as a plus b squared times a plus b. And we already know what a plus b squared is. That's this thing over here. So we can write this as a squared plus 2ab plus b squared. That's a plus b squared times just a plus b. Okay? And now we can expand these brackets. So we're going to get a times a squared times a squared times b. So we get a to the 3 plus a squared b. Then we can get 2ab times a, 2ab times b. That's going to give us, let's have a look, 2a squared b plus 2ab squared. And the last one we're going to get is going to be b squared times a, b squared times b. And so we get a b squared plus b to the 3. Alrighty, let's collect some like terms. A to the 3 is all by itself. We've got a squared b and 2a squared b. So that's 3a squared b. Similar here, we've got 2ab squared plus ab squared. That's plus 3ab squared. And then we've got plus b to the 3. So already we can kind of see a pattern, right? Here we've got 1 and 1. Here we've got 2, 1, 1, 2. Notice that the powers always add up to 2. So since it's to the power of 2, we've got a power of 2 here, a power of 2 here, and in the middle we've got 1 each. It's more noticeable on the cubics, right? Because we have to the power of 3. Now this one's to the power of 2, this one's to the power of 1. So they're still adding up to 3. Now this one we've got to the power of 1, but b to the power of 2, so it still adds up to 3. And we've got b to the 3. So each of these powers are always adding up to 3. It's just that we're splitting them up. And we're going to notice that even more so when we do to the power of 4. We're going to ignore the coefficients for the moment. So let's expand this one. Well, this one's just a plus b to the power of 3 times a plus b. Well, we already know what a plus b to the power of 3 is. It's this thing over here, so let's put that in. A to the 3 plus 3a squared b plus 3ab squared plus b to the 3 times a plus b. Now this is probably going to be the ugliest one, so I'm going to give myself a little space. Let's expand some brackets. Alrighty, so a to the 3 times a to the 3 times b. We get a to the 4 plus a to the 3b. Next one, 3a squared b times a. 3a squared b times b. 3a to the 3 plus 3a to the b3b plus 3a squared b squared. Next one, 3ab squared times a, 3ab squared times b. we get 3a squared b squared plus 3ab to the power of 3. Lucky last, change color. Let me find let's do this green. B to the 3 times a, b to the 3 times b, plus a b to the 3 plus b to the 4. Okay, this is just insane amounts of expanding brackets, but it all works out. Collecting like terms, we can see that we've got a to the 4 by itself, a to the 3b, 3a to the 3b, so these both have 3a's and 1b, and that gives us 4a to the 3b. The next one is a squared b squared. This is also an a squared b squared, so we've got 6a squareds b squareds. And here we've got 1a, 3b's. Here we've also got 1a and 3b's. We get 4a b to the 3, and we've just got b to the 4 at the end. Okay, so the question is there a way we can get from here to here in one step? And the answer is we absolutely can if we can notice the pattern. So let me clean things up and look at the patterns. Alrighty, so let's have a look at some of the patterns that are going on here. So we can see here the number of terms seems to kind of continue up in a pretty ordinary fashion. So we've got 2 terms here, we've got 3 terms here, 4 terms here, and 5 terms here. But the more interesting part is to look at what happens to the actual powers. We've got a to the 4, and then a to the 4 becomes a to the 3, which becomes a to the 2, which becomes a to the 1, which disappears. Or we can think of it as a to the 0. Similarly, we get b to the 0, b to the 1, b to the 2, b to the 3, b to the 4. Now that pattern happens for all of them. A to the 3, a to the 2, a to the 1, a to the 0, b to the 0, b to the 1, b to the 2, b to the 3. So as the a's are counting down in terms of the powers, b's are counting up. And notice that the powers always add up to the power we're taking it to. So in this case, 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 4 plus 0 is 4. So no matter what, you always end up with these terms like so. So then we go, okay, well that's great and all, but that's not going to help me expand the brackets if I don't know what the coefficients are. Well, this is where we can look at the coefficients. So coefficients here are 1 and 1. The coefficients here are 1, 2, 1. The coefficients here are 1, 3, 3, 1. And the coefficients here are 1, 4, 6, 4, 1. Let me move things over a little bit. 1, 4, 6, 4, 1. Well, this looks like a familiar shape, and in fact, if I put one more layer at the top, this is Pascal's triangle. The way you generate the next layer of Pascal's triangle is that it starts with a 1, and then you add the 2 terms next to each other. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then the 1 on the end. And in fact, these two things are related. And so we can expand any power of brackets just using these things. And that's what the next video is going to show you how to do. So, for example, if I wanted to work out what a plus b to the 5 was, well, it's going to be a to the 5 plus a to the 4 plus a to the 3 plus a to the 2 plus a to the 1. But that's not all. Then we're going to have, well, b to the 0, b to the 1, b to the 2, b to the 3, b to the 4, and b to the 5. Now, the only thing we've got to do now is put in the correct coefficients. Now, the correct coefficients are 1, 5, 10, 10, 5, 1. Get rid of the 1s because we don't really need them. And there we go. I just expanded 8 plus b to the power of 5. And all I had to do was learn a pattern. 5, 4, 3, 2, 1, 0. While looking at the other pattern. 0, 1, 2, 3, 4, 5. And then all I have to do is put the coefficients in based on this triangle. 1, 5, 10, 10, 5, 1. And there we are. So next lesson we'll look at expanding actual brackets.